other question relates to your modeling exercise. Do you also think of trying to incorporate the option of virtual water trade? And if it's kind of CDE or, because by way of doing that, we can also try to optimize what we use.
Yeah, I mean, the focus here really has been a bit on domestic and industrial, the benefit of domestic and industrial water productivity improvement, but we also improve irrigation at the same time. And in all countries, I mean, especially in developing countries, the scope for improving industrial and domestic water use efficiency is extremely high, much higher compared to the OECD countries. South Africa is a little bit of an exception because they have done a lot, among others because they are extremely water-scarce country. But even there, we still have scope for improving domestic and industrial water use efficiency. Across the irrigated world, the scope of improving efficiency is generally much larger. Agricultural sector is obviously domestic uses. I probably should have just shown a graph that shows, that about 80%, 78 to 80% of global water consumption is from irrigation, so depletion, and the rest is from domestic and industrial. So that alone tells you cannot. Even if you get down to zero, you still 78% is still irrigation. So definitely the relative scope is much smaller in domestic and industry, but the domestic and industry sector, at least in the developed world, and whenever they implement in developing countries based on their budget, they are actually doing it very efficiently. So they have made much greater strides in improving efficiency than irrigation could ever dream of.
I'm Elisa, agricultural faculty of the University of Bonn. What bothers me a little bit is you speak about the higher productivity using the water in the industry and so on. And then you mention again agricultural sector, irrigation. But I think we are sure we need a certain kind of irrigation, water use in agriculture, and cannot put all the water into industry. I miss a calculation how much water will be still used in agriculture and how the efficiency should be improved.
Yeah.
And what part of the water can be put into the industrial sector.
So, okay, so...
Because you have to feed the people.
Yeah, and the question is, so how much of future food production will be from irrigation, how much from rainfed? I didn't focus on these questions here, but so generally, because we keep improving agricultural productivity, we improve yield, and we do make some improvements in irrigation water use efficiency, especially in the water-scarce countries such as China, somewhat in India, but in lots of other countries. So we are saving. We are saving a lot of water also in irrigation. Relatively, in the industry, in a lot of industries, you can get down to 0%. You keep recycling, so you reuse everything. So the actual new withdrawals, keep going down, and the depletion rate keeps going down. So in industry, you have a much larger margin of increasing water use efficiency. In irrigation, the margin you cannot do as much. But even if you do very little, the impact is much larger because 80% of withdrawals are for irrigation. So basically, domestic water supply expansion is the one sector that will use quite a bit more water from irrigation. Industry, at some point, is this typical curve. So you will first go up and use more water, and then you'll become more efficient as economic growth improves, and then you'll use less water. No, overall, there's no huge shift from irrigation to domestic and industry. So there is at the margin, water is moving over from irrigation to domestic and industry. At the same time, we are developing more irrigation. It's not like it's not stagnant. So irrigated area is increasing. So we are developing more irrigation as well. So the final picture actually doesn't change that much. So it's not...
2050, it's still 70% agriculture?
Maybe 65%. So, but it doesn't change that much. So, because all sectors are growing. So irrigation is growing, domestic industry is growing. Domestic industry grows much faster, but they're also growing more efficient faster than irrigation. But at the same time, irrigation is expanding and also becoming more efficient. So the final one is a small shift from irrigation to domestic, which is all you need because the relative share of domestic and industry is not that large in total water use.
Have you made any modeling about the increase of population and the increase in the efficiency of irrigation?
Yeah. This is all included in the baseline, of course. I mean, just the UN median population rate, and just trend in slowly improving basin efficiency over time, which improves faster in the water-scarce basins.
But you said in your survey, industry said population.
Yeah, they think that's all that matters.
You said that with an undertone, the next 1.5 billion don't matter so much. Did you clarify?
No, and especially, okay, the next, I mean, the population increase matters a lot out to 2025, 2030. At least that's what we see. That's when we still have a lot of increase in demand. But then from 2025 to 2050, the additional population is very small. So the scarcity seems to be, the population pressure, most of the population pressure we have already reached 2025, 2030, and further out it flattens out already quite a bit. And then climate change and the fact that all the population keeps becoming wealthier, the fact that they're changing their diets is what I believe is a bigger impact. So the fact that they're becoming wealthier and the fact that we have climate change impacts, I believe, is a bigger issue by 2050. Whereas out to 2025, 2030, the population itself is a bigger issue.
Let's make a last round. Professor Bogali had one, Anik Baduri. Anyone else who would like to come in? Okay, and that's it.
Thank you. You mentioned water scarcity, and actually we deal with a one-dimensional water which has H2O. Any additional features, water quality, the cost of water purification or multiple use, as you have the river moving downstream, some of the Chinese rivers are rumored to be used 3 times, and certainly the cost...
Potomac water is used 7 times before it reaches DC, yes.
Okay. So could it be, or has it been considered in this calculations?
Yeah, no. So we did not, I mean, that's one of the areas we want to expand on. We want to incorporate some notion of water quality to the model. And actually Petra Doe recently reviewed our water models, and we also asked her for her advice, and she said, because again, the water quality models are so extremely complex, she suggested we should just do some transfer function. So we can calculate N input from fertilizer and livestock from the food model, and then she said just use basic transfer function, don't try to put on top another extreme quantity and calculate it based on that. But we haven't done that this point. We would definitely start very slowly, so don't factor in time. But as usual, this is a global model, so you cannot get at the local complexity. It's always a question of what question do you want to answer with some global water quality estimates. I think it might be interesting if you ask, so bioenergy, will it have an impact on water quality? Because generally they're trying, commercial production, so they're trying to use a lot of fertilizer as well. There's only so many questions you could answer by incorporating water quality, and you cannot incorporate it in a serious, in a very serious hydrological manner because we don't have full flow routing here. So then you have to develop a very full-blown 15-year effort flow routing model. And then you had one other question, sorry. That was it. Okay.
Could I interject a technical question? What's the research base of 0 to 20, 20, 40, about 40?
Sorry,
Yeah.
Okay. Falcon marks 74, but there's lots of others that I could somewhere. Yeah, so it goes back, there's a whole series of water scarcity indicators, and the UN generally likes to use so Falcon mark event I put down. Just looking at regions, so, it's a description. It's really a descriptive under 20%, we say generally we avoid local environmental impacts. If you go to 20 to 40%, so the regions that have this kind of scarcity levels, at least in the past, years old. I guess even today we see stress in drought periods, so there's simply some impacts from water scarcity, and then when we have above 40%, we see local impacts of over extraction, and the reality is we do see that, like North Africa, India, and so on. So it's a descriptive indicator. There's another one that says if you're above 1,700 cubic meters per capita, and you're water scarce, so that's even like, why 1,700, why not 1,500? You have to, at least this is something that's used across many groups, and so it's, consistent with what other people do, but otherwise it's just descriptive. It hasn't been done based on any biophysical assessment.
Anik Baduri is last.
Have you 2050 is a long period of time. There could be some technological change in agricultural production. That may, because even they use 65% of the water, that may change that number. Have you considered any factors like that?
I mean the blue scenario does consider higher yield improvement compared to what we consider as business as usual yield improvement. But of course there could be some biotech or other breakthrough that we haven't factored in, and this is generally the problem of any scenario analysis, that it's very difficult to factor in unlikely events such as the tsunami in Japan. So that could really affect it'll affect